ever connected to a computer, keyboard, mouse, charger, monitor, external drive, relied on a port. And yet, ports are one of the most confusing parts of modern technology. Many look the same, but behave completely differently. Some only move data. Some only send video. Some can do everything at once, but only if the cable and the port both support it. This confusion isn't accidental. It's the result of decades of technology evolving, overlapping, and replacing itself. In this video, you'll build a clear mental map of every major computer port, what problem it was designed to solve, and why it still exists today. USB-A. USB-A is the rectangular port that defined modern computing. Before USB, computers were full of different connectors for different devices. USB-A solved that chaos by introducing one universal standard for keyboards, mice, printers, flash drives, and countless accessories. Its success came from reliability and simplicity. Plug it in, and it works. Over time, USB-A improved internally with faster speeds, but the physical shape never changed. That consistency is why it's still everywhere today. However, USB-A has limits. It's bulky, not reversible, and struggles to support modern requirements like high-speed video and high-wattage charging. That's why newer devices are slowly moving away from it, even though it remains the most compatible port ever created. USB-C. USB-C is not just a new USB port, it's a redesign of what a port can be. It's smaller, reversible, and capable of carrying data, power, and video through a single connector. In theory, USB-C replaces dozens of older ports with one universal solution. In practice, it creates confusion. Two USB-C ports can look identical but behave very differently. One might support charging only. Another might support data but no video. Another might support everything at high speed. USB-C is powerful because it's flexible, but that flexibility comes at the cost of clarity. The port itself doesn't tell you what it can do. The implementation does. Thunderbolt uses the same physical connector as USB-C, but it operates on a completely different level. It was designed for professional workloads that demand extreme performance. Thunderbolt can handle ultra-fast data transfer, multiple high-resolution displays, external GPUs, and professional storage, all through a single cable. For video editors, engineers, and power users, Thunderbolt removes bottlenecks entirely. The problem is visibility. A Thunderbolt port looks identical to USB-C unless you see the lightning symbol. Even cables matter. Not all USB-C cables can handle Thunderbolt speeds. This makes Thunderbolt incredibly powerful, but easy to misuse if you don't know what you're looking at. HDMI is the most widely used DisplayPort in the world. It exists because people wanted a single cable that could carry both video and audio without complexity. Before HDMI, displays often required separate cables for sound and picture. HDMI simplified everything, which is why it became the default for TVs, consoles, projectors, and most consumer monitors. For computers, HDMI is reliable and universal. You plug it in, and it works. The limitation is scalability. HDMI is designed for one display per port, which makes it less flexible for advanced multi-monitor setups. Newer HDMI versions support higher resolutions and refresh rates, but its core design still favors simplicity over expansion. DisplayPort. DisplayPort was designed specifically for computers, not home entertainment. It solves problems HDMI doesn't. DisplayPort supports higher refresh rates, higher resolutions, and features like daisy chaining, where multiple monitors connect through a single port. This makes it ideal for professional workstations and gaming setups. DisplayPort also handles variable refresh rates more efficiently, which reduces screen tearing in games. The downside is adoption. DisplayPort is common on monitors and graphics cards, but rarely appears on TVs. It's technically superior in many ways, but HDMI dominates because it reached consumers first. VGA. VGA represents the analog era of computing. It carried video signals as electrical variations rather than digital data. This worked well when displays were simple and resolutions were low. As screens became sharper, VGA struggled. Analog signals degrade, causing blurry images and interference. VGA also carries video only, no audio, no data, no control signals. Despite its limitations, VGA still appears in older offices and classrooms because legacy equipment lasts a long time. When you see VGA today, it's not there for performance, it's there for compatibility. DVI. DVI was the transition point between analog and digital displays. It delivered cleaner images than VGA and supported higher resolutions, making it popular during the early days of flat panel monitors. Some versions of DVI could handle analog signals, digital signals, or both, which added flexibility but also confusion. DVI never carried audio, which limited its usefulness as multimedia became more important. As HDMI and DisplayPort matured, DVI lost relevance and slowly disappeared from modern systems. Ethernet. Ethernet is the most stable way to connect a computer to a network. Unlike Wi-Fi, Ethernet provides consistent speeds, low latency, and minimal interference. This is why servers, offices, and competitive gamers still rely on it. Ethernet ports are physically large and require cables, which conflicts with the trend towards thinner laptops. Many modern devices remove the Ethernet port entirely, forcing users to rely on adapters. Even so, Ethernet remains unmatched when reliability matters more than convenience. 3.5mm audio jack. The 3.5mm audio jack is one of the simplest yet most enduring ports. It connects headphones, microphones, and speakers in a plug-and-play way that has lasted decades. Early computers often had separate jacks for audio output and microphone input, which could be confusing. Modern devices combine these into a single TRRS jack, allowing both input and output through one connector. In spite of the rise of wireless audio and USB-C headphones, the 3.5mm jack remains popular for its simplicity, low latency, and universal compatibility. Audiophiles, gamers, and professionals still rely on it because it works without drivers, software, or interference.